Hello everyone, my name is Ege Vural. I'm a student in Bilkent University. My department is Electric and Electronics. Today I'll be presenting my lab experiment titled Experimentally Calculating Gravitational Acceleration Using a Simple Pendulum. The goal of this experiment was to calculate g, the gravitational acceleration, by analyzing the pendulum's period and understanding how factors like rope length and release angle theta will influence our results. Before diving into the experiment, let me explain what a pendulum is. A simple pendulum consists of a mass or bob attached to the end of a string or rod that swings freely from a fixed point. When displaced and released, the pendulum swings back and forth under the influence of gravity. The motion is periodic for small angles theta. It behaves as a simple harmonic oscillator. This is because for small theta angles, the approximation sin theta equals theta holds true. This makes the restoring force directly proportional to the displacement, satisfying the criteria for simple harmonic motion. The period t, the time for the full oscillation, is given here. By rearranging this equation, we can calculate g by 4 pi square L divided by t square. And in this equation, t is the period, L is the length of the rope, and g is the gravitational acceleration. This is the pendulum system that I prepared for my experiment. In here, we start the experiment by attaching a 60 cm rope to a fixed point and a weight at the other end. When we release the weight at angles of 5 degrees, 10 degrees and 15 degrees, measuring the time for oscillations at each angle to observe how the pendulum behaves. After completing the measurements with the 60 cm rope, we repeat the same process using a 100 cm rope. This allows us to compare effects of different rope lengths and angles on the pendulum's motion and the calculated gravitational acceleration, providing insights into how these factors influence the results. And let's watch all the experiments. This table shows the results obtained from the pendulum experiment using a 60 cm rope where the system was tested at 3 different angles, 5 degrees, 10 degrees and 15 degrees. At 5 degrees, the period of the system was measured as 1.51 seconds. The calculated gravitational acceleration was 10.39 meters divided by second square, which is higher than the expected value of g. This resulted in a percentage error of 5.91%, indicating a moderate overestimation of g. At 10 degrees, the period increased slightly to 1.57 seconds. The calculated gravitational acceleration decreased to 9.61 meters divided by second square, which is slightly lower than the expected value. The percent error here was 2.04%, showing a small underestimation of g. At 15 degrees, the period decreased marginally to 1.55 seconds. The calculated gravitational acceleration was 9.86 meters divided by second square, very close to the expected value. The percentage error was only 0.51%, indicating highly accurate results at this angle. After the experiment that we used 60 cm rope, we also tried this experiment with a 100 cm rope, and this table presents the results obtained when the system was tested at angles of 5 degrees, 10 degrees and 15 degrees. At 5 degrees, the period of the pendulum was recorded as 1.9 seconds. The calculated gravitational acceleration was 10.94 meters divided by second square, which is significantly higher than the expected value of g. This resulted in a percentage error of 11.52%, indicating a substantial overestimation of g. At 10 degrees, the period increased to 1.96 seconds. The calculated gravitational acceleration decreased to 10.28 meters divided by second square, closer to the expected value, but still higher. The percentage error reduced to 4.79%, showing a more accurate calculation at this angle. At 15 degrees, the period decreased slightly to 1.94 seconds. The calculated gravitational acceleration was 10.69 meters divided by second square, again higher than expected. The percentage error increased to 8.97%, indicating less accuracy compared to the 10 degrees. And these are the plotted versions of our results. In conclusion, we calculated gravitational acceleration by using pendulum and observed the effects of angle and rope length. The 60 centimeter rope gave more accurate results, especially at 15 degrees, while the 100 centimeter rope consistently overestimated g, likely due to timing errors and air resistance. Despite these deviations, the experiment demonstrated the principles of simple harmonic motion effectively. Thank you for watching.